Tonight's speaker is our own David Johnston, who is a NASA Solar System Ambassador, and he's going to be talking to us about Mars machines. So without further ado, all the housekeeping is done. Dave.
Tommy, can you guys hear me okay? Good. Before we jump into the presentation tonight, Tommy has suggested that maybe I can take a few minutes and talk about the upcoming Star Party at Perry. This will be what we'd like to think of as our first annual Perry Star. It's going to lead off with Thursday, October 23rd. We're having an astrophotography class taught for beginners, taught by Tommy himself and David Krause. It's going to be hard to get into at this point. We've already got 8 people, which is our supposed cap. I think we could expand to 10. So if there's anybody here who's interested, please go to Perry's website and look for the astrophotography class. Then on Thursday and on Friday and Saturday, after the astrophotography class, that's the 24th and 25th of October, we're going to have a 2-night Star Party. Not ready to tell you who the speakers are going to be on that Saturday, but I will tell you that we'll have experts in meteorites, radio astronomy, and quite possibly exoplanets, and that all the speakers are awesome. So if, again, we're filling up quickly though, we have capped it at about 50 people. And last I checked, we had over 30. So if you're interested, please, before it gets too late, go to Perry's website, look for Perry Star or Star Party on the website. And normally I would show that up here, but this is not my computer. Please, sooner rather than later, go and sign up. I'm really excited about it. It's going to be a ton of fun. Christy.
Also, Perry also has monthly events as well, so that's worth going there to see what kind of monthly events are there. So that's very well done as well.
Yeah, so as Christy said, we have as well monthly events, especially for meteor showers. We always do meteor showers, and anytime there's something unique happening in the night sky, we'll try to put on an event for that. In addition, if you know somebody that's interested, you can even book somebody like me to spend a couple hours in the extremely dark skies up there, and we'll pull out the big 25-inch scope and have some fun. So all of that stuff is available through the Perry website, and just know that you're going to support a STEM nonprofit education venue that could use the support. So thank you for that. Now, as Tommy mentioned, I'm also a volunteer for NASA and the Jet Propulsion Laboratory in a program called the Solar System Ambassadors, which sounds just magnificent, but we don't actually get like Venusian cigars or anything like that. However, what we do get to do is we get to sit down with the engineers and scientists that do all the things that NASA is famous for. We get to hear straight from the engineer's mouth what they're doing, and then we get to go out and talk about it, which is how this presentation got pulled together. Summer of 2024, I was preparing a talk for a Perry summer camp, and it was going to be on Mars and the Martian terrain and how it gets to look the way it looks. And I happened to sit in on a presentation by Rob Manning, who was, and still is, JPL Chief Engineer Emeritus. Now, Rob has been involved on, I guess, every single Mars mission since Viking. Is just an amazing resource and somebody who's extremely generous with his time and his work product. So I hit Rob up and he said, sure, I could use his presentation. Now, some of what you're going to see tonight is going to come from Rob, some is going to come from me, and some is going to come from other sources. But for sure, thank you, Rob, because this would not be what it is without him. Also, I always feel compelled to thank the Jet Propulsion Laboratory, Caltech, and NASA for allowing this program to take place. It gives people like me a chance to go out and talk to people like you about the amazing things that NASA does. And finally, thanks you guys for letting me come and talk to you. I appreciate it. It probably goes without saying, but I'm gonna just check anyway. Sometimes when I do these talks, I misjudge what my audience is most interested in. Just want to make sure we are all actually interested in space exploration, right? Okay, this is an astronomy club, but it always pays to check. So why are we so interested in space? Well, we're interested in space for the same reason why we're interested in everything else. We're curious. We're a deeply curious species, right? So we explore the oceans because we want to know what's down there. We dig into the ground and analyze what we find because we want to know what's under our feet. We study the weather, partly because we don't want to get rained on, but also because we're just generally interested. Space is, to some extent, the same sort of thing. But it begs the question, so since we've been able to leave the Earth's atmosphere, we have sent probes to Saturn, we have sent probes to Pluto, we've been inside the sun's atmosphere. We've landed a very short-lived lander on the surface of Venus. We've been to asteroids, but nothing have we explored to the extent of Mars. We have spent so much time and effort exploring Mars. Why Mars? Mars, next to the very planet that we're standing on, Mars is the most inviting target in the solar system for people who might want to go visit. When you think about the other planets in the solar system, none of them are very appealing. I mean, they're appealing scientifically, but do you really want to go to Mercury, where it's extremely hot and there's zero atmosphere? Venus, acid rain, 800 degrees, crushing pressure, right? Mars is in the liquid water zone around the sun. It has a little bit of atmosphere, not a whole lot, but a little bit of atmosphere. And it has the benefit of being relatively close by. But there are other reasons too. And before we go further into that, there are some things. So this presentation tonight is going to be a little bit heavy on engineering. Part of the reason for that is I actually have a background in robotics. And in fact, when some of the things we're going to look at tonight, when those things were going on, I was actively involved in doing robotics research. But not well, but I was actively involved in doing robotics research. So as we're going through the presentation tonight, I'd like you to think, keep in the back of your mind a few things. First, it's really hard for us to go to Mars, really hard for humans to go to Mars or anywhere else in the solar system, right? It's dangerous. So we send out robots. The reason we send out robots is because robots are good at the things that we're bad at. Robots can be built to handle tough environments, much more difficult environments than we can. You don't have to send biscuits with them, right? They have solar panels or they have a radioactive pile. They eat that energy directly. Robots, well, I was going to say robots don't get bored. Maybe I shouldn't speak to a robot state of mind, but we have no evidence that robots actually get bored. humans, a long trip to, let's say you wanted to go to Saturn, it'd be a long trip and you'd get really bored. So we send robots. And finally, as far as we know, they don't mind the fact that it's a one-way trip. We send robots when we know that getting back from the destination is going to be really hard. So thank the robots, please. But the other thing, while robots are good at some things that we're bad at, they're also really bad at some things that humans are good at. Robots could not solve a unique problem to save their lives. And frequently, if you're cruising around another planet or out in deep space, it really is to save your life, right? So throw up an unexpected problem to a Mars rover, for example, it's not going to be able to solve that problem. The best that you can hope for is that it's going to avoid dying in encountering that problem. The other weird sort of lack in robots, they have no innate abilities at all. Robot capabilities are entirely dependent on what we can tell them to do, and their ability to accomplish those tasks is entirely dependent on us being able to tell them the right way to do that. So robots are robust and stupid is basically what I want to get to. The other thing to keep in mind, and you all know this, there is a substantial communications lag exploring anywhere beyond basically lunar orbit, right? So on Mars, that time lag, the round trip communication time, is anywhere from like 6 minutes to 3/4 of an hour. If your robot is falling off a cliff, even a 6-minute delay is too much. It's dead before before you can tell it what to do. So when we send these robots out to do these dangerous missions, we have to imbue them with as much intelligence as we can. But we've already talked about the fact that robots aren't inherently smart. So keep in mind, one thing that robots are really good about is when they see something they don't understand, they stop and wait for us to tell them what to do. And then finally, I don't know if there's anybody in here who's a computer geek. I got a degree in computer science and so on. But if there's anybody in here who's into computers, as I talk about each of these rovers in turn and each of the Martian landers in turn, I'm going to talk just a little bit about their computing power. I want you to remember that there is a substantial time lag between the time that a robot is conceived of to go out and explore a place, then gets built, then goes to that place, right? So you're talking 5 years to 10 years for most of these, which means that we're going to be talking about, even on the most modern rovers, we're still talking about kind of old computer systems, right? So keep that in mind, and as you're comparing, say, the capabilities of Spirit and Opportunity to the capabilities of your cell phone. Okay, so from time immemorial, our ancestors looked up at the night sky. You're all amateur astronomers, you've all heard this before, but we've looked up at the night sky and we identified that there were fixed stars and that there were wandering stars, right? And those wandering stars, we come to find out, are actually planets. Well, we couldn't learn much about those planets other than their when they rose and set and so on, until we developed technologies that would allow us to see those planets, right? So we all know about Galileo and turning the telescope on to Jupiter and seeing the moons of Jupiter. Well, for just about as long, early astronomers, at just about the same amount of time, they began looking at Mars. So up on the screen here, on the upper left-hand side, you have what may be the first sketches of Mars through a telescope. These are from Francisco Fontana in the mid-1630s. I can't say with certainty that those are the first sketches, but they're the first ones, the oldest ones that I've run across. Upper right-hand side, we see sketches that were made by Christian Huygens over several decades during his career. So that would be in the later 1600s. Lower left-hand side is a bit of text from Jonathan Swift from his Gulliver's Travels, where Jonathan takes all the astronomy knowledge of his time and synthesizes a description of 2 moons of Mars, gets the orbital characteristics within an order of magnitude correct, one of them almost exact. It's remarkable. It's remarkable because that's 150 years before Deimos and Phobos were discovered. He took his knowledge of astronomy and used that to predict that there would be 2 moons orbiting Mars and get the orbital characteristics at least pretty close to being correct. Finally, lower right-hand side up there, that is one of the notorious drawings from Schiaparelli. Now, those of you who are unaware, Schiaparelli was observing in 1877. Now, his claim to fame, so to speak, is the sketches that he made. 1877, there was a major opposition of Mars. Mars was very close and a really good position to be observed. So he made these sketches, and on these sketches, he put straight line features and labeled them canali, which means channels in Italian. However, that got mistranslated to canals in English, which led to a Mars craze, because if you're going to have canals on Mars, you have to have canal builders on Mars. So, left-hand side, that is the cover of one of Edgar Rice Burroughs' John Carter of Mars novels. He wrote a bunch of them from the early 1900s into the 1920s. I liked this one. It was particularly lurid. But he wasn't the only one, of course. H.G. Wells with his War of the Worlds and so on. It really became a thing to begin thinking about Mars. And it's worth keeping in mind that even as we look back on that and we go, well, from our current perspective, that was a little bit silly. But even into the 1960s, we still thought that there might be life on Mars. On the right-hand side is an excerpt from an old popular astronomy book that I picked up at the used bookstore in Waynesville. And in it, a hypothetical visitor is visiting a hypothetical observatory and talking to a hypothetical astronomer, and he asks, what do you think the Maria are? Now, that's the Martian Maria. And the astronomer goes on to say that due to the appearance of change, we think that vegetation is growing on Mars seasonally. And he goes on to say at the end, it looks as if vegetation were springing up, brought to life by moisture from the polar cap. So that was into the 1960s. When I was about 8 or so, a bookmobile came to our school, and I bought a copy of a book called Podcane of Mars. I want to say it was, maybe it was Robert Silverberg. I forget who the author was. Robert Heinlein, thank you. And thank you. I should have known that somebody in the audience would know that. Do you know whether Podcane was the Martian or the girl? The girl, okay. And so that was well into the 1960s. Speculative fiction still was imagining that there was life on Mars. And by the way, folks, I just noticed that I do not have my notes because I don't have a computer over here. So I'm doing this all without notes. We'll see how it goes. Finally, before we get into the nuts and bolts of things, there were some absolutely stunning visualizations of what Mars and Martian exploration might look like in the 50s and 60s. This is from the book, The Exploration of Mars, by Wernher von Braun and Willy Ley. Obviously, you all know who von Braun was, the sort of father of everybody's rocketry. I was going to say American rocketry, but the father of rocketry. Willy Ley was an enthusiast who was really into rockets as well. He wrote a column for Galaxy magazine back in the day. And the illustrations, the incredibly gorgeous illustrations, are by Chesley Bonestall, who is really sort of the epitome of the golden age of science fiction's illustrations. I'm going to go back 2 slides real quick. All of the images here are from that book. And that book is available free of charge on the Internet Archive. So if you're interested, and I highly recommend to any space enthusiast to go back and read this book, it is available. I will say, so you remember when Seth Shostak was here, and he said, for every equation that I put into a slide deck, I lose 10% of my audience, right? Well, I do have to warn you, that book has equations, and it has diagrams. Still well worth doing. I don't know if I need to convince you that Mars was once a wet place. And here admittedly, I'm getting a little ahead of myself. We're gonna get there in a slower slog in a minute. But I do not know if I need to convince you or not. But if you need convincing, on the left, we have a picture from orbit of the Nile River Delta. On the right, we have a picture of the Neretva Valley and what sure looks like the Neretva River Delta to me. I can't tell you what Schiaparelli saw that were the straight line features, but I can tell you right now that had he seen what you're looking at, I think the enthusiasm for Mars would never have waned. All right, now the hard part. Robots are stupid, keeping that in mind. Every craft that we send is, to some extent, a robot. We got to the moon first, so the Soviet Union decided that it wanted to go to Mars, to get to Mars before we did, so it built a set of robotic spacecraft. Now, right now, the list that you see up there is only the landers. There were also orbiters. Most of the orbiters also failed. So I'm just going to go through the list really quickly and mention a couple of things about a couple of the probes. Mars 2, 3, and 6. Mars 3 actually landed safely on Mars. That's the Russian spacecraft. Actually landed safely on Mars and then croaked before sending back anything even remotely useful. But we'll give that, so you'll see it's color-coded. It gets an orange for being almost working. You'll notice that Mars 4 and 5 are missing. Those were both orbiters. One of them actually went into orbit and worked. The other one crashed on the surface. Well, we don't know that it crashed on the surface. We just know that it never phoned home, so to speak. All right, but then Viking 1 and Viking 2. Now, some of you in this room are probably old enough I'm old enough to remember these. These were, well, we'll get into the details in a little bit, but huge accomplishment. The first probes to ever land on another planet successfully. That was 1975 when they landed. It was 1996 before we attempted another landing. Mars Pathfinder Sojourner, very successful mission, part of the, Faster, Better, Cheaper, or Cheaper, Faster, Better, or something like that. program from Dan Golden at NASA. Very successful mission. 1998, Mars Polar Lander died. It's 2 probes that it was carrying, DS2, the micro probes, gone, no, never heard from. Complete failure. Also part of the better, faster, cheaper. So it turns out maybe better might not have been the right word to use for that program. The Beagle 2, interesting probe, lander from the European Union, failed. It landed, but it couldn't communicate because its solar panels never uncovered the high gain antenna for it to talk to Earth. Then, success. Success after success after success. Spirit, Opportunity, Phoenix, Curiosity. I'm going to skip Schiaparelli for a moment. Insight, Perseverance and Ingenuity, and China's lander and robotic rover, Tianwen and Zhurong. Schiaparelli was a sad screw up. That was a Roscosmos and European Space Agency and Roscosmos, the Russian Space Agency, combined on a program called ExoMars. They sent a rover that crashed, a lander that crashed, but they also put an orbiter around Mars that has done great things. This is the Trace Gas Orbiter, and it has been looking at methane coming up off of Mars over time. That's an important thing. Methane could potentially be a sign of life. Methane doesn't stay around in highly irradiated areas. Mars is highly irradiated, which means that methane is probably being produced somewhere on Mars. We know that from that spacecraft. The only other one I want to mention, well, we'll get to it. We'll get to it in a little bit. This is a sort of a scatter plot of where the various landers have landed. You'll notice that somewhere on. Oh, there. So you'll notice Zhurong and Tianwen are fairly far north, and Phoenix is even further north. You notice, so the color code here is altitude. So blue is lower, red is higher. You'll notice the entire northern section of Mars is low. That remains an open mystery for scientists. We don't know why the entire northern part of Mars is so much lower than the southern part of Mars. However, there is new data on that, which we'll get to when we get to the right rover. And then finally, we have an overlay that gives you the names of the features that we have landed near. For orientation's sake, I will show you Olympus Mons and Tharsis Montes and the Hellas Basin. The Hellas Basin is the lowest area on Mars, and Olympus Mons is the highest. And now, these are the 2 rovers that remain in service on Mars. 21 straight years we have had rovers active on Mars. 21 years of exploring another world through our robotic emissaries. Brief timeline, don't really need to go over this too much except to point out, as you probably are aware, to get to Mars in a reasonable time and with reasonable amount of fuel, there are launch windows. So if you look at the timeline, you will see that there are launch windows and that in many cases, or in some cases, there are multiple launches during those launch windows. Again, I'll point out that there's 21 years between Viking and Pathfinder. We're going to talk about Viking in just a minute. And maybe afterwards, I'd be interested in hearing your take on the Viking findings. I'm just going to skip over this is another timeline. This one that shows both rovers and orbiters. It's important to know that those orbiters are up there because in many of the cases, the way the rovers communicate to Earth is actually through those orbiters. I believe one of these orbiters may be on the chopping block for NASA, by the way. Probably should have checked that out. All right, Viking. In many ways, Viking was the first truly successful Mars mission. Both Viking landers landed safely. There were Viking orbiters as well, by the way. So the Viking orbiters inserted into orbit just fine. The landers landed. These robotic landers were essentially all that they were meant for was to look for life on Mars. Each one had 4 experiments, and any of those experiments were intended to look for traces of not organic materials, but actual life function. Half of, in what was truly an unfortunate outcome, half of the tests showed life, half didn't show life. Since then, people involved on both sides of the argument, they've been battling it out ever since. Some have said that there were that Earth bacteria had contaminated the experiment that showed life. Others say, no, not so much. So, really interesting question. A lot of time and effort to ultimately come back with, yeah, we still don't know. However, what we did learn is that from these landers is that there's virtually no magnetic field on the surface, that the surface appears to be, at least to the limited chemical experimentation that these landers were able to do, that it was probably sterile. Very negative return from these, which soured people on exploring Mars for a long time. But something happened between Viking in '76 and Pathfinder in, well, whenever it was, '97. We discovered extremophiles on Earth. These are organisms that live in places that you wouldn't expect organisms could possibly live. They live in acidic environments. They live in boiling water. They live in the tiniest of cracks in rocks. They live in the worst possible conditions. We didn't know that in 1976, but we learned it in the coming decades, and suddenly Mars didn't look like such a bad place after all. We could tell it was dry. We could tell that it was irradiated, but it turns out maybe those things aren't necessarily always fatal to life. Next up, 1997, Mars Pathfinder, and the Sojourner rover. The Sojourner rover was a little bit bigger than a shoebox. If your shoes aren't iron, though, it was a lot heavier than your shoebox. On the left-hand side of the screen there, you can see how it landed, which is really kind of amazing. Coming in from orbit, obviously, these things pick up a lot of speed. You got to slow them down before they hit the ground. So you pop out parachutes. But we've already established that Mars doesn't have much of an atmosphere. Parachutes are of limited use. So this particular lander came down under a retro rocket pack, for lack of a better term, a set of thrusters that helped to slow the speed as it was plummeting. Then for the last, I'm not sure, couple of 100 feet, it actually dropped, wrapped in these monochrome beach balls, right? It hit and bounced on the surface. And the design of the beach ball mechanism was amazing because it had different flaps that could open to let the rover out. It had an accelerometer that would tell the system what the orientation was, and then it opened the right flap to flip the thing up in the right orientation to let Sojourner out. And that was about the end of the technical sophistication for this particular mission. This was very much a test of concept. We didn't know how to drive robots around on another planet. We didn't know really how to communicate with robots on another planet. Didn't know what the environment was going to be like. Not really. I mean, for all we know, the rover might have driven off the ramp and into a sinkhole or something, right? We didn't even know if glue would work. So this was a test bed for a lot of very basic technologies, including, by the way, an adhesive test. They glued the solar panels down with different kinds of adhesive to try to figure out which ones were going to last. It had a stereo camera on the front so that it could know where it was going. It had a weird red-green infrared camera on the back because they were interested in, I guess you go to another planet, you don't know what a daisy is going to look like, but you can imagine that it might be warmer than its surroundings. So they wanted to know if there were any infrared sources around there. And the rover, as you can see, doesn't have much of an antenna on it. It couldn't go more than about 100 meters from the lander because that was what it communicated through. Eventually, the lander froze to death. Sojourner, the rover, actually had its own little radiothermal generator. That's a device that generates electricity out of the heat being generated from the decay of radioactive material. So it had its own little RTG, radiothermal generator. If any of you have seen The Martian, if you'll recall, Mark Watney goes out and rescues Sojourner and uses the heat from that radiothermal generator to allow him to survive driving back to his habitat. As he said, one of the first things they teach you in astronaut school is don't dig up the radiothermal generator. They're dangerous, but they're really not that dangerous. And boy, have we used the heck out of them. Here's a view. One of the interesting developments from running this mission was that so we call the people responsible for where the rovers go, we call them the rover drivers. They don't drive the rover, they upload code to the rover. One of the problems that they ran into, though, was that the people responsible for this mission were on an Earth schedule. But a Mars day is a little bit longer. So we learned from this mission that the people driving these things around, the people that had to be available for these robotic emissaries, they couldn't be on a regular Earth schedule. So we learned that they had to time shift their daily lives. And that became, well, that was, when you hear them talk about it, it's really miserable living a 25-hour day when everybody else is living a 24-hour day. By the way, in the picture, you can see, I think I forgot to mention that Sojourner did have one scientific instrument on it. And that was, I believe it was an X-ray spectrometer. And you see it bumping up against a rock there to try to understand what the materials in the rock are. Okay, so when is a lander not a lander? when it's a crash lander. I've shown you the successful landers, and I've shown you that there were many unsuccessful ones. This I left in here because it is an absolute lesson in proper engineering. So this was one of those faster, better, cheaper missions, right? Well, part of the faster part meant that NASA and Lockheed Martin, who was responsible for building this spacecraft, did not spend as much time communicating as NASA had grown accustomed to, right? So we have the climate orbiter that landed in 1999. The reason it wasn't an orbiter anymore is because Lockheed Martin was speaking English standard measurement and NASA was speaking metric. So that lesson resonates through engineering teaching to this day. I've spent, well, up until retirement, I spent about a dozen years teaching science and engineering to kids in the Charlotte area, and this is a classic don't do this example, right? Make sure that the people you're working with are using the same system of measurement. Hey, guess what? Another faster, better, cheaper mission that failed. This was Mars Polar Lander. I think I mentioned this earlier. It had 2 microprobes that it shot out. They were penetrators, with the idea being that the lander would be able to look at the holes that they made and determine, you know, to some extent, what was in the holes, what material had been vaporized by those holes, and also just to look and see if there was like water seeping up or anything. As far as we know, it ejected the 2 penetrators and then it crashed to the ground. That picture in the middle is the terrain that it was trying to land on. So it doesn't look very friendly. Another non-mission is the Mars sample return, 0305. I left that in here. Some of you may be aware that recently another Mars sample mission got canceled. Mars sample return mission got canceled. This one was really, really long on design. It was in the forefront of everything that NASA was doing. Unfortunately, it wasn't even remotely realistic. But the idea was, this lander, by the way, is huge. The lander was going to land, put off a rover. The rover was going to go dig up samples, bring the samples back to the lander. The lander was going to put them in rockets and launch the rockets into Mars orbit, where they were going to get picked up by a spacecraft that was going to return the samples to Earth. Brilliant, brilliant idea. Completely impossible for the time, but brilliant idea. So that got canceled. And just so you know, a lot of times these missions that get sort of started up and then canceled, they actually have work product. They actually have built something. NASA's really good about reusing that stuff, though. So NASA reused the instrument pack from the Pathfinder lander. Okay, as it turns out, that instrument pack was excellent. I can't remember the character's name, but in Contact, the super rich engineer who pays for the, anyway, he says, why build one when you can build 2 for just twice the cost? So NASA builds extras because you expect things to break. You want to do testing. They leave copies of things on Earth, so when something unexpected goes wrong, they can try to reproduce the problem on Earth, because you can't go to Mars and do that. So they took the instrument pack from Pathfinder, stuck it on wheels, and called it a rover. And hence we got the Mars exploration rovers, also known as Spirit and Opportunity. Now, the images that you see, and here again, I have to really thank Rob for these. He put this stuff together. The images that you see they take place over the course of less than 3 years. So from the time they thought of the idea of pulling the instrument pack off their duplicate Pathfinder and putting it onto wheels and getting those launched was less than 3 years. Remember I said earlier that sometimes 5 years or a decade might be, right? These are 3-year missions that happened in the course of 3 years. And you guys all know this story. They go to Mars, they're expected to last for 90 days. Spirit lives for 7 years. Opportunity for 12 or 13, I believe it's 12. These were mobile geometry labs, mobile geology labs. They were equipped with instrumentation, and I would give you the list of instrumentation, but since I don't have my notes, these were mobile geology labs that were able to sample the surface. They had lasers that would ablate, that would burn the surface of rocks, and spectrometers that would look at the material that was given off and be able to determine what those materials were. They ran on, I want to say these were 85, IBM 8085, or early, they may have been early IBM RISC chips. Don't worry, but the point is, these were specially radiation hardened, almost off the shelf computing elements. Limited memory, I think Viking had something like 18 kilobytes of memory and tape drives that it would store data on. Pathfinder, I think Pathfinder had the 8085. By the way, 8085 chip, that went on to become, well, it was closely related to the IBM 8086 and 8088 chips, which everybody had at one point because that was what was in IBM PCs. It had, I want to say, it did have more RAM, more than Viking, but still tiny by today's standards. Well, these guys are an upgrade, and one thing that we learned from the earlier missions is that you absolutely have to radiation harden your computing equipment. So these things are built with very sophisticated versions of completely off-the-shelf materials. I'm sure they paid $5,000 per chip or something, but they would stand up to the radiation on Mars. Robot arm that could do a certain amount of digging. It had mass spec. I don't think this one had a mass spectrometer, but these guys were able to determine the makeup of the rocks that they were looking at to some extent at the elemental level. So they learned what elements were available. By the way, landing system, same as Pathfinder, only for some reason they made the beach balls even more boring, and they're just white now. But the same landing system. So this landing system has worked 3 times in a row. So naturally, they completely changed the landing system for the next one. Probably also worth mentioning, you guys may have noted, anybody want to tell me what's up there that's unexpected? Yeah, the Lego minifigs, right? Well, it turns out that a group that I'm rather fond of and have been a member of for decades, the Planetary Society, convinced NASA to put Lego minifigs on each of these rovers. Upper left is Sandy Moon Dust, as I recall, and lower right is Biff Starling. And Biff and Sandy exchanged emails on their way to Mars and after they got to Mars. And my daughter and I sat in my oversized office chair every day and read their emails back and forth. Sandy was really smart. Biff was nice. But I think I can draw a direct line from that experience to my daughter going on and becoming a flight controller at NASA. So public relations really work. Spirit and Opportunity, as geologists, their main task was to try to understand water on Mars. I say that Mars is the best place for humans to visit in the solar system next to Earth. Part of the reason for that is, as I mentioned, it's in the zone where liquid water could exist, right? It's not so far from the sun that water would freeze, so close to the sun that it would boil off. Nevertheless, there is no standing water on the surface of Mars. Well, these two rovers helped to understand that, but also helped realize that there was abundant water on Mars, just in the form of ice, just below the surface. And this also, the Viking landers lasted for 4 years, something, 4 to 6 years. One was 4 years, one was 6 years. Perseverance, or not Perseverance, Sojourner, the rover lasted for about 3 months. All of those were within design specs. It was at about this time when NASA realized that Scotty from Star Trek was right, that when you're talking about the engineering that you're producing, you should always underestimate its capability by a factor of 10. So these two guys, 3-month initial missions, 3-month extended missions that turned out to be 7 years and 12 years. So we've got geologists roving around and telling us about what Mars is like now. But to really understand, we needed to send a chemistry lab. We have geology lab, now we need the chemistry. Chemistry is going to tell us on a larger scale what Mars is made up of now. And also, we need to do chemical experiments to understand where the water is, or more to the point, where the water was and what became of it. So we sent Mars Phoenix. Mars Phoenix was our first attempt at what was essentially a chemistry lab. It was fairly limited, but in one of those wonderful acts of reuse, NASA was able to throw this together for very little money based on the platform from the Mars sample return mission that had been canceled in 2003. So they took the platform and just repurposed it. The biggest, this thing had the usual set of spectrometers and so on. The biggest takeaway from it, though, had a robot arm that was strong enough. Well, so first off, as it was landing, it blew a bunch of the regolith, the Martian dirt, away, and then it was able to scrape through the dirt with its robot arm. You can see from the picture that it didn't penetrate very far, but lo and behold, just beneath the surface, water ice. What an astonishingly direct experiment. It dug a hole, and there was water ice. By the way, this is the furthest north we ever landed. I believe it was like 68 degrees north, something like that. But unable to move around, not designed to move around. So now, let's put a mobile chemistry lab in place. This is Curiosity. As many of you will know, Curiosity is still bopping around, and I realize I'm quickly running out of time. Curiosity is still bopping around on Mars. It's been there for 13 years now. Its landing system was really amazing. It was what they called a sky crane. So it started off as usual with parachutes. Then the sky crane actually lowered the lander out from underneath it and set it gently down on the surface. No more beach balls, no more bouncing around your delicate scientific equipment. Instead, a nice general set down. Of course, what you have to worry about, you don't want the rockets to be pointed at your lander. That would be bad. And also, what happens to the sky crane after it releases the robot? You got to make sure that it doesn't just fall on top of the robot, right? But all of that was accomplished. What was really astonishing about this, I talked about robotic intelligence. This thing was built in such a way, programmed in such a way, that it could hover and make decisions on its own where it's going to put the rover down. Yeah.
When the Curiosity landed, they had a live program in the auditorium of the North Carolina Museum of Natural Sciences in Raleigh.
They did.
And they filled it up.
And I was watching this online at the same time. So since I'm running out of time, we won't go through this in any great detail. But they liked that method so much that they reused it for Perseverance. Chemistry lab, it would be hard to go through all the things that this rover discovered. It has found clays, which only form in the presence of water. So many discoveries of organic materials and so on. Well, boy, I'd love to go through all of this stuff. Oh, by the way, this is a fake picture. I mean, it's a real picture of Gale Crater, which is where Curiosity landed, but Rob digitally dropped the rover in. But he made sure that we all knew that it was fake. He didn't get it from ChatGPT. This is, on the left, a sort of a close-up of the kind of terrain that it was driving through. And on the right, a look at the effect on its wheels. Those wheels are being torn asunder. NASA learns from its mistakes. Not that that was a mistake. They simply did not know what to expect. By the way, those buttes up there, those are sandstone. This is pretty obviously a dried up riverbed or lake bed. This is Mount Sharp, which is in the middle of Gale Crater, and it's taller than it looks. I forget the exact height, but it's a couple of thousand meters tall, I believe. This is the instrument package. As I mentioned, chemistry labs. So the robot arm would dig up samples, dump them through a door into the chemistry labs. Here's the robot arm digging in the dirt. That is the first hole that it ever dug. It went on, it's dug somewhere on the order of 40 or 50 more now. A few results. Upper right-hand side, you see a result from the X-ray diffraction device, which definitively identified clay. Clay, as I mentioned, forms in water. It's also a great home for bacteria, by the way. Lower right, the mass spectrometer, SAM. Heated up, regolith discovered, sure enough, water, as we were coming to expect, carbon dioxide, O2, molecular oxygen, sulfur dioxide. Most importantly, you see the blue signal of H2S, that's hydrogen sulfide. On Earth, hydrogen sulfide is bacteria food. So we know that there's energy source available close to the Martian surface for Earth-like bacteria to thrive. It does. I believe this was the first to have a mass spectrometer. Now it's, so without getting too far afield, Europa Clipper, which is unsurprisingly on its way to Europa, it's going to fly through plumes of water coming through the cracks in Europa's ice, sample that water, send it through a mass spectrometer, and look and see what we might find. Finally, a few months ago, 6 months ago, Curiosity uncovered long-chain hydrocarbons. It was thought that big molecules like this wouldn't be able to survive in that radiation environment. Turns out they can survive in that radiation environment, which gives hope that maybe someday they'll dig up a spoonful of amino acids or something. That would be really cool. Real quick, Mars Insight. This was sent to Mars to learn about Mars's interior. It has a seismograph, and it listens to the echoes of meteor strikes on Mars's surface and uses that to map Mars's interior. It also has a device called the mole. The mole's intent was to dig down into the Martian regolith and learn about the temperature differences between the upper levels and lower levels to try to understand if there was heat coming up. It turned out that in one of those unknown things, the mole could not dig in the Martian regolith. The regolith didn't have enough friction, basically, to drag the mole down as it was trying to dig. They even took the robot arm and beat on the top of the mole, trying to drive it down into the dirt. It just never worked. However, we did learn from, and have learned from recent analysis of the data from InSight that probably the Martian lowlands are caused by internal influences within Mars's crust, not from some sort of a collision or something like that. And then I believe that just within the last week or two, additional analysis has been done that shows that maybe Mars's core is completely solidified. There may not be any molten area inside Mars at all, which fits with the idea that Mars doesn't have a magnetic field, a planet-wide magnetic field. Real quick, I'll go through this. This is, these are the different rovers. Sojourner, Spirit and Opportunity. This is Curiosity. Perseverance is a little bit bigger. And that is what Rob hopes is going to be on Mars sometime within his lifetime, which would be a human buggy, a buggy driving humans around on Mars's surface. But for now, these are the actual ones, and you get a look at their sizes. The Tianwen-1 lander, Zhurong rover, I can't tell you anything about it because I don't know anything about them. Not my fault. Blame China. They don't talk much. Landed in 2020, lasted until 2023. Don't know much about the findings. Can't tell you much. Finally, Perseverance and Ingenuity. I'm running out of time. You know, you guys all know about Ingenuity, the helicopter, right? Crazy idea that NASA engineer had. Hey, let's see if we can fly a helicopter on Mars. You can't fly a helicopter over Mount Everest on Earth, or it's very, very difficult to do that. And the atmosphere is 4 times thinner on Mars than it is at the top of Mount Everest. But crazy engineering ideas, NASA is willing to entertain those if you can put them together and do something with them. So they built a helicopter. It was supposed to fly 5 times, flew 72 times. It was supposed to basically jump up and down, wound up flying around more, actually was used to identify possible targets for the Perseverance rover. This is a shot of the sky crane from the top of the rover. Please note, it did not fall on the rover. This is also a fake picture because there aren't any cameras up there to get this perspective, but this was from an Earth simulation. Instrument pack. Lots to talk about here, not a lot of time. Ultraviolet spectrometer on the end of the robot arm, goes and pushes up against things, is able to determine molecular composition to a certain extent. It has an X-ray spectrometer on the end of it. It's got the super cam, which shoots out lasers. The camera shoots out lasers, and it has 4 detectors on it in different wavelengths, so that it can look at the ablated material, the burned off material, and see what was in it. But there's so much here, so much that I could talk about. But I do want to mention MOXIE, which you see on the lower left. MOXIE was our first attempt to develop what we refer to as in situ resources. This is an experiment that produced oxygen, breathable oxygen, out of the carbon dioxide that's in Mars's atmosphere. It cooked Mars's atmosphere in such a way that it could pull off the oxygen and save that for humans to breathe. Or, I suppose, penguins, if you sent penguins.
Moxie is also Lowe's store brand of paper towels, bathroom tissues.
Well, I'm absolutely certain that's what they named it after. This is where it's wandering. I showed you this picture earlier. This is the area that Perseverance is exploring. This is Jezero Crater, in which it landed. There's all kinds of interesting stuff in Jezero Crater. Wildcat Ridge, Skinner Ridge. Wildcat Ridge produced or has Chiava Falls. So first off, those ridges, which on Earth we would think of, oh, you mean like a mountain ridge. They're this tall, right? They're a couple of inches tall. Chiava Falls is a rock that has what looks for all the world like leftover bacterial reaction to hematite. Hematite is the mineral that makes Mars look red. Hematite is also used by bacteria as an energy source. When bacteria use it as an energy source on Earth, they leave behind a sort of a white spot, a chemical poop, if you will, that shows that they've been there doing that. Well, you can see there's a white spot. I don't know, does that look like bacteria poop to you? I can't tell. But also, this rock has olivine in it. Olivine is formed in the presence of water. And finally, this is a sample that is sitting in a sample return tube. I mentioned that Perseverance was just like Curiosity, except kind of beefed up. Kind of failed to mention that it had one additional system in it. It has a system that digs up samples, drops them into tubes, seals the tubes, and then drops the tubes out on the ground for a later craft or rover or helicopter or whatever else they come up with to come by and pick the tubes up so that they can be returned to Earth. So they're planning for a Mars sample return mission that right now may never happen. I will say, though, that NASA did take proposals from private companies to go and fetch these things. But very likely, this very tube has the information that we want to know as to whether or not there's existent or whether there ever existed bacterial life on Mars's surface. It's sitting in a tube waiting for us to go get it. Here's a picture of the tube scattered about on the ground. This is Rob's art group's interpretation of what the Mars return mission might look like someday. Finally, just want to wrap it up and say, I taught kids this summer at a camp at Perry, and you know, high school kids, they really want to know, is there life out there? I don't know. I can't answer that. Had to answer this question in so many times in so many different ways. I do not know if there's life, other life out there. If we're going to find it within my lifetime, it's going to be from these types of experiments. It's not going to be, we're not going to find Marvin the Martian running around someplace. We're going to find evidence of bacteria. If we could go get that bacteria, that evidence of bacteria, bring it back to Earth, or send a lab that could do the right kind of analysis, I really think that we could eliminate the idea that there was ever life on Mars, or, in my opinion, more likely confirm that our distant cousins are out there. That's it, I think. Everybody, thank you. I hope I did okay without the
Great present. You have something else? Hang on.
Can I just say one more thing? My wife was teasing me about the fact that I've been through this talk 5 or 6 times completely over the last few days. I'm really glad I did.
Pays off. A great presentation, fascinating. Thank you so much, David. You know, think about your takeaways from everything he talked about this evening. My takeaway is the mole. If it's something that's not working properly, you might want to take a hammer to it. That might help a little bit. So now it's time for questions and answers. Who has questions? We'll kind of pass these mics around.
Just a comment on something you said. A NASA administrator who is no longer with NASA said, faster, better, cheaper, pick two.
Yeah, I like to say it was faster, worse, or more expensive. I mean, it's granted, the spacecraft were cheap, but when they crash without ever being heard from again, that's just money down the drain. So, yeah. Oh, come on. Somebody's got to have a question. Thank you.
Sean.
Howdy. Do you know with those samples that they have lying around there, do they have like little GPS markers on them at all? Or, because like if a dust storm comes in, like I can imagine it could be pretty hard to find them if they get covered in dust.
Yeah, of course, you run into the problem with there's no GPS system.
Yeah.
So, they've marked them as best they can. Thanks to modern technology and the orbiters that are going around there, they actually do kind of have a GPS-ish system in place. They are more or less marked. But what you guys have to remember, these rovers, top speed, maybe 1/10 of a mile an hour, right? So you're on Mars for whatever, 13 years. You still haven't gone very far.
Yeah.
So all they got to do is look for the rover and then look back on the markers. But like you say, dust storm comes up, they're gone.
Yeah. Here you go.
That one slide that you had that had the list of all of the different missions that they've done, which one was the one that the dust storm covered the solar panel and it died because it couldn't get any sunlight?
Yes, Spirit was the Mars exploration rover. Spirit was now that all of them have had this issue at one time or another. Anytime you're relying on solar panels on Mars, they're going to get covered. One of the really weirdly interesting bits of NASA research is how do you dust a solar panel that's millions of miles away? Yeah, you can't really use your robot arm to take a cloth up there and wipe it down. As it turns out, despite the fact that the atmosphere is so attenuated, the winds are frequently enough to blow the sand off of the solar panels after they've gotten on there. The problem with Spirit was that it got into an area where the wind wasn't able to clear the panels off. It is an interesting problem, though. RTGs, you don't have to worry about that, right? So you send a little pile of plutonium along, and it's going to last as long as it lasts. You don't have to worry about weather.
Oh, sorry.
Did they ever find any of those crashed orbiters? I know you had a map that,
Yes.
like,
Yes, in fact, gosh, this is in my notes. I wish I had it in front of me. But Mars Reconnaissance Orbiter picked up Schiaparelli. Well, they kind of knew where Schiaparelli was, but they picked. It also picked up one of the early Soviet crashes. They do look for those things during their spare time. I mean, who wouldn't? Anybody else?
I thought something was just super interesting when you said that they only the rovers go a very short distance per day. With Perseverance, they actually added a system where it can kind of maneuver itself a bit instead of having to require human intervention all the time, which was, I think, huge. And also, if anyone wants to look at a video, they have a video of the entire entry to Mars from Perseverance, from the parachute coming down to the crane. It's super cool.
So this talk almost turned into a talk about astronomy and robotics. Then I remembered that we're an astronomy club. But but that was what I did in college. Tommy, do I have time to tell one quick story? Okay, so about the time of Spirit and Opportunity, when they were being conceived of, I'd gone back to college and was beginning to do robotics research. My friend Paul Wiegand and I inherited a robot from, or not inherited, but borrowed a robot from one of the professors. It was a Nomad 2000. It looked like a larger, fatter version of R2-D2. It was basically it was a cylinder with wheels, right? It was a trash can, but it had sonar and infrared. And so what we were supposed to do for our project, we had to build a vision system that would combine the input from those sensors into a sort of a unified picture of its environment. We did the programming, simulated everything. Everything worked great. We downloaded it to the robot, and instead of creating a nicely behaved 200-pound cylinder that moved around the humans very nicely and everything, instead it became an attack robot. It went after everybody. It turns out it couldn't see denim, right? Well, if there's one thing that's not in short supply in a college lab, it's denim. So as soon as we tried to demo it, it would go off in a direction, and if there was a human there, it didn't care. And it's 200 pounds, right? So point being, it's hard to do robots in a lab setting. Can you imagine how hard it is on another planet? So you have to build that kind of autonomy in. I didn't get to talk about it. There is an upcoming mission called Dragonfly, which is going to go to Titan, and it's going to fly around on Titan for 5 years, and it's going to be nearly completely autonomous, because it has to be. It's going to be very far away in a very thick atmosphere. It's got to be able to think for itself. So the algorithms that go into this stuff are just incredible. Love that stuff, but I guess that's for another club. Anybody else?
Any activity from China or Russia? Do we have any way of knowing what they're up to?
We're talking about on Mars.
Yes.
Well, we have a fleet of spacecraft in orbit around Mars. All of them have high definition cameras. So we can see anything that's going on Mars. Mars has the benefit, except during sandstorms, it's pretty clear. So you can see from space right down to the ground. Having said that, we may know what they do on Mars, but we may not know what they're doing on Earth to get to Mars. And there is a pretty good body of evidence that China has a 10-year plan in place that will have it back on the moon and then on Mars. It's basically similar to the Artemis program that NASA has, but they're moving right forward with it right quickly. So it's very likely that they're going to get back to the moon before we do, and that they'll get to Mars before we do. But maybe not. Maybe SpaceX won't blow up any more rockets for a while and make some progress.
Thank you.
And they go to Venus instead.
That's a great idea, because Venus is such a friendly place. All over the place.
Me. I have sort of an engineering question. As you know, advancements in processing power keeps steadily going up, so does their power draw. So on new rovers that are being made, or the latest rovers and stuff, is there like a bottleneck with it in relation to power consumption versus putting the latest processor on?
Yeah, so that's a really, really good question. That's why RTGs are the answer. That's why we don't use solar exclusively anymore. RTGs have as much power as you need them to have, and you can convert as much of it as you want. Well, I mean, within reason. They don't have enough power to blow up a planet, but you can use any amount of the heat that it produces using thermocouples. You can use any amount of that to produce electricity. One of the really cool engineering moves ahead with, I guess, I'm not sure about Curiosity, but with Perseverance, it actually, instead of converting all the heat from the RTG, or as much of it as it can, into electricity, then running a heater to keep the instruments warm, instead, it just uses whatever amount it needs of the heat, the generated heat, to produce electricity to run the instruments. They're kept warm through waste heat from the pile, which is much more efficient than trying to convert it into electricity, then convert it back into heat. So, yeah, RTG is the answer to that question.
Cool. Thank you.
But yes, the power draw definitely goes up. One thing I'll say though, as we get better at making these instruments and miniaturize these instruments, the instruments that have to be powered are actually drawing less electricity than the older instruments. So there is a trade-off going on, or a balance going on.
What's next? What's currently being developed?
So, okay, I have to be careful here. As some of you are aware, maybe all of you are aware, the situation at NASA has changed. It's difficult to know what's coming next. What I can tell you is that as of this moment, the Artemis program is still going forward. And the idea with Artemis is that we go to the moon first, learn how to live someplace else, learn how to make use of resources that are available to us, then humans go to Mars. Whether that's still going to be the case next year or whatever, I couldn't tell you. To the best of my knowledge, there aren't any plans for any more dedicated Mars rovers from NASA. However, everybody's getting in on the space business. The United Arab Emirates launched in that same window that gave us Perseverance. They launched an orbiter, and that orbiter is still looping around Mars. It's actually been retasked. It's now studying Mars's moon Deimos. So it's been up there for years now doing its thing. You have China, you have India. Canada has its own spaceport. Everybody's getting into this, including the private sector, by the way. What's next may be to go get those samples back from Mars. Various companies have put forward ideas about how to do that. One called Rocket Lab has put forward a financially attractive idea and they say that they can go and get those samples and get them back before 2030. So we'll see. We'll see what's next. I have no idea.
I just want to. I want to add on to your answer about the CPU size and feature or like power draw. The smaller that, or like the more powerful processors have much smaller transistors, and so they're much more susceptible to radiation problems. And so when you're trying to rad hard in any sort of electronics, people actually prefer to just keep the feature size bigger, like almost microns sometimes, because they're just way easier to protect. Yeah.
It's also true of the non-volatile memory. Right? You have to be careful about radiation on memory because you want the data you get back to be actually accurate. So let's harden that too. It's there's always trade-off. I mean, my PC at home that I run right now is much more powerful than the desktop PC that I used to have. Draws less power, right? But it's not it's not getting pelted by radiation from the sun or by cosmic rays like everything on Mars is.
I actually have a quick question about Ingenuity, the helicopter. So we know that you can't do high rescue missions, on Mount Everest or anything like that. And you may not know this question, but you may. What was different about that helicopter blade, or was it something in the engineering that made it possible for it to fly where we can't fly?
The answer to that is yes. It was the blade, and it was so the material that the blade is made out of. The tilt of the blade, the size of the blade relative to the mass of the aircraft. To get a similar ratio, the blades on, say, a rescue helicopter would have to be 100 yards long or something. I'm pulling that number out, but blade size to mass is part of it. The cant of the blade matters as well. For what it's worth, the probe that's going to Titan, the Dragonfly probe, is actually a dual quadcopter. It's got two sets of 4 copter blades, just like your typical drone, right? Only 2 of them. But the engineering there is much easier to work out because Titan's atmosphere is twice as thick as Earth's. The thicker the atmosphere, the better the helicopter works. The only reason you've got 8 blades on this thing is because it's going to be flying around for 5 years and something's going to break, so you want redundancy. Really an amazing, so I mentioned the mole, how the mole couldn't dig down into the dirt. Dragonfly isn't relying on a robot arm for drilling. Instead, it's got passive drills on its landing struts, and every time that it lands, it's picking up samples and loading them up into the craft to be analyzed. I should really quick, another really cool innovation there. It rains on Titan, but it rains liquid methane and liquid ethane. So you've got cold liquid pouring onto your space probe, not something that NASA really deals with on a regular basis, right? So you've got sensors that have to be out exposed, and you have to have some sort of path from the sensor back to the computing equipment, right? So instead of running straight paths, they have what they refer to as tortured paths. As the liquid hydrocarbons go down into these holes that lead back to the computing equipment, they go through a long path and they get gradually warmed up, sublimate back into gases, and then go back out through the hole they came in through. Now that's the theory, right? We've never done this before.
Hi. So this is more of a geology question, but so we're pretty confident that Mars used to look really similar to Earth like billions of years ago. And on Earth, if you go in a riverbed, for example, and sample that soil versus going like on the top of a mountain, like they're gonna look pretty different. So like, do you suspect that taking samples from like Olympus Mons, for example, versus a dried up riverbed on Mars, do you think the soil will look pretty different or kind of similar?
It does look pretty different. And you saw the scanner map of where all the different landers have gone, right? Mm-hmm. Everywhere they land, stuff's a little bit different. You saw the picture I had with the Chiava Falls, that rock. Mm-hmm. Even when you look at that rock, within that rock, there's a huge amount of variation. That only happens when stuff is transported and mixed in together, right? So yes, everywhere you look, it's different.
And do we expect to like go to different areas? Like, I guess in your opinion, you think we'll start going to more, because all the rovers are kind of on that one line mostly?
Well, so that one line, I've debated about talking about this. That was actually a complete layout of Mars. It went from, minus 90 degrees, plus 90 degrees, right? And 180 degrees in each direction. So that was the entirety of Mars. The reason they were all sort of on that line represents the bulk of Mars, right? So they were, we've landed everywhere from 68 degrees north to, I want to say, 30-something degrees south, maybe further south than that. they've chosen the landing points so far based on what they think the geology and chemistry of those areas are. But everybody really wants to go explore Olympus Mons and the whole Tharsis Highlands area. There's so much that you could learn by looking at the layers that are revealed there, but it's hard to drive a robot there.
Thank you.
You mentioned the lack of a magnetic field on Mars allows solar radiation, solar particles, charged particles, and cosmic rays, which requires you to radiation harden all the electronics that we've talked about several times. My question is, what are plans for radiation hardening humans?
That's a really good question, and the answer is caves.
Yeah.
So the beauty, so we're beginning to learn that while surface radiation can be really nasty, it doesn't take that much shielding to protect you from the radiation. So the idea is we live in caves. So first off, I have no idea if we're ever going to live on Mars or not. I might go if I had the chance, but I think the answer is we live in caves. We work in radiation-shielded vehicles or buildings. We make sure that we're monitoring radiation exposure, and we let robots do most of the running around on the surface. To be honest with you, that's really the answer to just about any question exploring the solar system is let's do whatever's necessary to keep the humans safe and let the robots do the dangerous stuff. Europa Clipper is going into a horrifyingly grotesque radiation environment around Jupiter because Europa goes around Jupiter in its radiation belt. So humans will never go and explore the surface of Europa. So let's let our robots go do that, and let's keep humans where they're safe. Now, say that, when the robots develop sentience and start objecting to this, they're going to come after me first. But yeah, let's let the robots do the dangerous stuff. It's the way we do in the oceans, right? We send unmanned submersibles into the depths to learn about things, and we sit up where it's nice and safe up on the deck of the ship and sip our boat drinks or whatever. So it's the right way to do it, I think. And also it's the cheapest way to do it because it's very expensive to build spacecraft that will keep humans safe. It's not expensive to build spacecraft that will keep robots safe. Is that it?
Okay, if there are no more questions, thank you very much, David. We appreciate it. Now, it is time to, for those of you who are waiting for this moment, to buy your raffle tickets, because in just a couple of minutes, we'll raffle off our telescope and tripod and the Mission on Mars book. So get your raffle tickets.